In this lesson, we explain how to move some objects in a 3D environment. As you can see, in this environment there are three particular objects: a helicopter, a triple wheel, and an ATV. We can move these objects, and for this we use some particular tools, and a panel called Keyframing is used to set the parameters to move the objects. There are two kinds of tools: static tools, used to establish the base orientations and positions of the objects, and dynamic tools, used to create an animation that will be managed in this interface but used in the Visual Show Director. This animation is created inside of the Keyframing panel, in which you can see the timeline needed to set the cue, which are the times in which you can change the animation of the objects. For example, you can change the position, the orientation, and so on. In the Object to Modify field, you find the list of objects to animate. Then we have the Show Object Transitions checkbox, which allows you to view a preview of the animation. Finally, we have the Repeat Count field that allows you to establish the number of times that the animation will be repeated. Now we will see how the static tools work. First of all, you have to select an object. To do this, go in the Object Hierarchy panel. You can see a tree that shows the hierarchical structure of the site. The tree's root is the name of the site. The root subnodes represent the objects inside the site. The subnodes of the previous node are the pieces that define a specific object. For example, we select the object ATV, that is the node called ATV. You can see that when you select a specific object, in our case ATV, in the viewport is shown the vectorial base of the selected object and the bounding box that covers the selected object. To move an object, you can use the Move Object tool. And you can move in two ways: manually with the mouse, clicking with the left mouse button on one vector of the vectorial base to move it. The other way is by using the X, Y, Z vector fields, inserting a quantity expressed in meters. You can move the object in the direction of the vectorial base. For example, if we put 10 meters in the X vector field and click on Apply, then the object will move 10 meters on its X vector. Another way to move the object is in reference to the positions in the environment. To do this, you can choose the position from Existing Position field. For example, you can choose B03 and click on Apply. As you can see, the object is put on the selected position. To restore to the previous position, go to the Undo menu. We continue our lesson with the tool called Rotate Object. This tool contains the same parameters as the Move Object, and it works in two ways: manually or with the Tool Options panel. Manually, you can select a vector with the left mouse button and rotate the object around that vector by moving the mouse. The other way is to set the parameters in the Tool Options panel. The rotation is expressed in degrees. So for example, we can rotate around the Y vector and put 90 degrees in the Y vector field and click on Apply. You can see that there is a rotation of 90 degrees in a clockwise direction. Another option that allows you to rotate the object around a position is the Existing Position field. For example, choose Pivot, put 45 degrees, and select XZ plane. Finally, click on Apply. You can see that the object is rotated 45 degrees around the pivot position. Continuing the lesson Keyframing, we explained the tool called Resize Object. This tool works in 3 different ways. The first one is manual. That allows you to resize the object manually by selecting the directions in which you want to resize the object. After you have selected the directions, go in the viewport and click and drag to resize the object. For example, if you check the X resize, the object enlarges or shrinks in the X direction of the vectorial base. You can select all 3 directions. The tool increases or decreases the size of the object in all 3 directions. The Custom option allows you to increase or decrease the entire object based on a particular field, that is, the percentage. If we put 100 value, then the object doesn't change size. If we put a value greater than 100, then the object increases. If we put a value less than 100 value, then the object decreases. For example, insert 200 and click on Apply. You can see that the object becomes larger. The final object is 2 meters, which allows you to resize the object to fixed measures. Set the measure in X, in Y, or in Z, or in all 3, and click on Apply. These measures are expressed in meters. So, for example, if we put 3 in the X measure field and click on Apply, in the viewport you can see that the object called ATV changes its size in the X direction. If you set Y measure to 4 meters, then the object also increases in the Y direction. In this part of Lesson 5, we will see how to create an animation of an object using the timeline. This component contains the cues that are the times where the object changes its state, movement, orientation, and so on. To create a cue, right-click on the timeline and select option Insert New Cue. A red vertical line appears to represent the position where the cue will be inserted. With the left mouse click, you create a cue in the selected position. The cue just created represents a command to move the object. The object moves in a time interval depending on the cue times. In our case, we have created a first cue at 1 second. So, the object will change its position or orientation in 1 second. The same applies if we have 2 cues. Between the 2 cues, the object will change its position based on the time difference. The cue created can be selected and moved. To select the cue, click with the left mouse button on the cue itself. Notice that when we select a cue, a yellow bounding box appears in the viewport. This box represents the new object position and orientation relative to the selected cue. To move the cue, select the cue, and while holding the left mouse button, move the mouse and release the mouse button when you have chosen a new position. If you want to delete a cue once a position is selected, use the right mouse click and select the Delete Selected Cues option. You can select multiple cues by using the Control key with the mouse. For example, let's create 3 cues in the timeline. To select all 3 cues, keep pressing the Control key, and with the left mouse button, select the 3 cues. To delete them, click with the right mouse button in the timeline and select Delete Selected Cues. In this part of Lesson 5, we will see how to fill the cues to establish a particular animation of the object. Each cue can contain a set of modifiers, which is a command that modifies the animation of the object, like movement and rotation. To create a modifier on a cue, first we have to create the cue. Click with the right mouse button in the timeline and select Insert New Cue. Click with the left mouse button to create a position, for example, 1 second. Now select the cue with the left mouse button. In the bottom part of the Keyframing panel, we have the property grid that shows the modifiers relative to the selected cue. To create a modifier, click with the right mouse button on this grid. A new menu appears that shows the availability to add or remove. We have 3 types of modifiers. The first is translation. This modifier allows establishing a linear movement from the current position of the object to another position. We have the internal rotation modifier to establish an internal rotation. The object rotates around its vectorial base. Finally, we have the external rotation modifier. The object rotates around an arbitrary axis and point. For example, let's select the first option. The property grid is automatically filled with the newly created modifier. We can add multiple modifiers to a cue. The procedure is the same. Click with the right mouse button on the property grid and select, for example, the internal rotation option. We can see that every time we add a new modifier on a cue, a new section appears in the property grid with the same name as the modifier, and below it, the relative properties. To remove a modifier, click with the right mouse button on the property grid and select the option relative to the modifier that we want to delete. So, to delete the translation modifier, we have to select the Delete Translation option. Now we will see how to fill the modifier's properties. The first type of modifier is the translation. This modifier moves an object in relation to its vectorial base. So this modifier has 3 properties: x, y, and z movement. These values are measured in meters, and they refer to the vectors of the object. We can modify these properties in 2 ways: manually, by inserting the numbers in the below properties, or with the tools of the 3D Position Editor. With the first way, for example, let's put 10 meters in x movement. We can see that the object moves 10 meters in the direction of its x vector. Since the cue is put at 1 second, the object will follow this animation, and it will take 1 second to move 10 meters in its x direction. The same applies for the other 2 coordinates. With the second way, we have to use the Modify Translation Vector tool that changes the movement vector with the GUI. Click on this tool and click with the left mouse button in any of the 3 yellow vectors to change the movement. Notice in the viewport a green vector appears that represents the movement vector that the object will follow when this animation will be executed. When we use this tool, the properties in the modifier are automatically filled with new values. In this way, we can easily move the object to any position. In this part of Lesson 5, we will see the internal rotation modifier. This modifier allows the object to rotate around its vectorial base. Let's create a cue at 1 second and add internal rotation modifier. This modifier has 3 properties: pan angle, side angle, and tilt angle. These three properties are rotation angles around respectively the y, z, and x vectors of the object. With the first way, for example, let's put 30 degrees in pan angle. We can see that the object bounding box is rotated 30 degrees around the y-axis. This means that the object will take 1 second to rotate 30 degrees around the y-axis. With the second way, we have to use the Modify Internal Rotation Angles tool that changes the three angles with the GUI. Let's click on this tool and click with the left mouse button in any of the three yellow vectors to change the rotation angle relative to that vector. For example, if we click on the Y vector, we automatically change the pan angle in the property grid. This applies for the other three coordinates. We continue Lesson 5 with the Modify External Rotation tools. To use this tool, as before, you have to create a queue inside the timeline. So let's put a queue at 1 second. Then select the queue. In the property grid, click with the right mouse button and select Add External Rotation option. As you can see, you have several properties. We have Rotation Angle, field that establishes the rotation angle for the object expressed in degrees. Then we have the X, Y, and Z axis coordinate fields that establishes a vector that represents the rotation axis. This will be used to rotate the object around this vector. Finally, we have the X, Y, and Z center coordinate fields that establishes the center of the rotation. We can do this manually or with tools. Since this tool is composed of many parameters, it's preferable to use the tools directly. In this case, there are three. Modify External Rotation Center Vector changes the center of the rotation. The third tool, Modify External Rotation Axis, displays the rotation axis as a green vector. To establish the rotation angle, click and drag in the green vector. Angle changes the rotation angle. Notice that the yellow bounding box around the axis, representing the new object position, tool, Modify External Rotation Center Vector tool, once activated, displays the center of the rotation as a blue vectorial base. To move, click and drag with the left mouse button on any vector. For example, let's put the center of the rotation in this position. The second tool, Modify External Rotation Axis tool, once activated, displays the rotation axis as a blue vector and a green vectorial base, fixed in the position where we established the center. It is used to rotate the axis around the three standard vectors X, Y, and Z. To do this, just click and drag with the left mouse button on any green vector. The third tool, Modify External Rotation Angle tool, displays the rotation axis as a green vector. To establish the rotation angle, click and drag in the green vector. Notice that the yellow bounding box, representing the new object position, rotates around that axis. As for other tools, all of the changes made are automatically updated in the property grid. In this part of Lesson 5, you will see an example of animation using the 3D Position Editor keyframing. The car will make a simple circle path around the three-wheel object. First, we rotate the car so that it faces the right side of the three-wheel object. To do this, first we have to select the car object, going in the Object Hierarchy panel and selecting the ATV node. To rotate the car so that it faces the right side of the three-wheel object, select the Rotate Object tool and rotate the car around the Y vector. We can use the Y vector field to rotate automatically the car. In this case, we put 90 and click on Apply. Now we can create the animation in the timeline. Let's create a cue at 2 seconds and select. Use the right mouse click in the timeline and select Add External Rotation. This tool is used so that the car rotates around the three-wheel, an external point. Select the Modify External Rotation Center Vector tool and move the center of rotation so that it matches with the center of the three-wheel object. We don't select the Modify External Rotation Axis tool because the rotation axis is always the standard Y vector by default. Finally, we have to change the rotation angle. The car turns completely around the three-wheel object, so the car must do a 360-degree rotation. Instead of using the tool, we can enter the value 360 inside the Rotation Angle field. In this part of Lesson 5, we want to use this animation inside the script of Visual Show Director to see the effective simulation and the real movement of the object. The Keyframing panel exports a string representing the effective animation that we create for a particular object. To export this string, right mouse click on the timeline and select the Export Keyframing String option. This string is automatically put inside the Windows clipboard. Go back to Visual Show Director and paste this string inside the Object field, for example, in this cue. Before running the simulation, we have to tell the viewer that the script is changed, so we press the Export Viewer File tool. Now we can run the viewer. We can see that the object is initially put in the position that we established in the 3D Position Editor. When the music reaches the cue where we inserted the string, the object starts to move, according to the string's content, which is the animation that we created. To modify the animation, we have to copy and paste the string that is present in the script and go back to the 3D Position Editor. Right-click on the timeline and select the Import Keyframing String.